So welcome to the project demonstration of hybrid power generation. So in this one hybrid sources we are using solar plus wind and hydel. So these three sources along with grid also we have placed to charge this battery. So whenever we place the solar panel in the sunlight, it will generate up to 12 volts, and that voltage will be given to the battery through this charging circuit. So here we are using three charging circuits. Each source consists of one charging circuit and common charging circuit for the hydel and transformer grid. So coming to the flow, so solar panel to this charging circuits. So there we can see four diodes. The diodes purpose, initially the four diodes purpose is like here we generally these four diodes are connected in a manner of bridge rectifier. So when we provide the DC inputs, so this bridge rectifier will work as a polarity corrector. Means if you connect the input power supply plus minus in reverse polarity also, this rectifier will rectify that and make it as plus to plus and minus to minus in the output end. So that's why we are using this bridge rectifier 4 diodes as a polarity corrector. And after that there are the 2 diodes. So the diodes purpose is current limiting as well as current flow opposite, uniflow current flow, uniflow for the current flow from the solar panel to the battery. So whenever the battery is fully charged, it's going to be the low potential one whenever the sunlight is not available, and when the battery is fully charged, then there is going to be the high potential. So then these two diodes will oppose the flow from battery to the solar panel. So that's in that way we are going to protect the solar panel from the battery whenever the sunlight is not available. Same purpose for these two charging circuits, but here so we are using this charging circuit for the hydel as well as for the grid transformer. So here when we provide the DC source inputs, then these 4 diodes act as a polarity corrector. But when we provide the AC input from the transformer, so here we are providing 230 volts input AC to the transformer, it will provide us 12 volts AC output. So then these 4 diodes will work as a bridge rectifier, will convert the alternating current to direct current, and from there same diodes, and here the capacitor will act as a like smoothing purpose. So there will get the pulsating DC after this bridge rectifier. So the capacitor will remove the pulses and make it as a smoothing DC, and that output given to the battery directly. So in this one, the 3 sources along with one extra grid source, directly we are going to charge this battery. When we provided the parallel power supply for the battery, then we'll get the more power and the battery will get charged in less time. And the next, so we are making use of inverter. So on this inverter we can observe the one L, nothing but inductor, and one capacitor. These two will act as a LC oscillator to provide the 50 Hz of frequency. So that 50 Hz of frequency will be step up with the help of this step up transformer and the MOSFETs. So that will be step up to 180 to 250 volts based on the battery voltage and the load connected. So that 2 volts given to the load directly. So just by switching on this, we can get the output voltage at the load end. So in order to charge a battery from the solar panel, so just connect the S at the S end, and so due to this tube lighting, low lighting also, we are getting the power supply. That's why there is a light indication on the solar charging circuit, and there is a wind, and next hydel. So let us demonstrate with the transformer. So if you want to charge a transformer, if you want to charge a battery with the help of transformer, so it will be fully charged in a duration of 8 to 10 hours. You need to keep it charging for 8 to 10 hours, whether it's a sunlight or a solar panel or a hydel or a wind or a transformer. So right after time completion, you can disconnect this and you can reconnect the hydel. Right. Okay, so as I know, only the lighting is available, that's why we are getting power supply on the charging indication, and when the wind is available, you can see the indication on the charging circuits. So the same manner hydel. So for the coming to the hydel, so this is the inlet actually. This one is the inlet for the water. We should place this under the tap. So at the same fins, the water falls, and the fins rotates. There we get the power generation from the dynamo, which is backside connected one. So you can see that. Right. Okay, in this way we can charge a battery with the help of 3 different sources and 1 grid power source. Thank you.